So just a little bit of a review before our quiz. If we have something like this, and let's say that this is 9 inches, and this is 40 inches, what's x going to be? Okay, how do we know what's A, B, and C? Well, the one that we always know is C. Which one is C? The hypotenuse, so the longest side. So C is x. It's the side that does not touch the right angle. It's the side that we call opposite or across from the right angle. The two shorter sides are the two sides that make the right angle. They make the L, are called the legs, and those are A and B. And it doesn't really matter which one's which. I call this one A and this one B. What the heck? So how are we going to write this out now? 40 squared plus 9 squared equals x squared. And then? So what's 40 squared? 1600. What's 9 squared? 81. That equals x squared. Then what? We add them together. 1600 plus 81 is 1681. Oops, 81 equals x squared. And then square root. The square root of 1681 is 41. This is 41. Questions? No? Cool. So I want you to try this one in your notes. Find x. So the first one, what'd you get? 60. Perfect. How about this one? 5.46? 25.46? That might work. That's what you got? Okay. That works for me. Okay, next one, next step. Yeah. I know it's review, but it's stuff I want to make sure you know before we hit the trig. Come on. Okay, so let's see here. Find x and y here. Now I will tell you this. This angle and this angle are the same, and this angle and this angle are the same. Find x and y. So how do we find, where do we start at least? What's our first move here? So the 15 and the 9 match up. So it's 15 over 9 is our first ratio. That's either enlargement or reduction ratio, magnification factor if you want to call it that, scale factor, however you want to call it. We know that the side that started out as 15 in this figure became 9 in this figure. Now in the next ratio to complete our proportion, we need one of them to be x or y, depending on which one we're looking for. So let's assume we're finding x first. Is that going to go top or bottom? Top, because it's from the same figure as the 15, so it goes with the 15. Now what goes below it, of course, is the corresponding side from the other figure, which is the 24 is the corresponding side. So now if we cross, multiply, and divide, 15 times 24 divided by 9 is, what is it? 40. Very good. This is 40. To find y, do the same thing, only y goes bottom because it's from the same figure as the 9, so it goes with the 9. What goes above it? 45. We cross, multiply, and divide. 9 times 45 divided by 15 is 27. Y is 27. It's not going to let me edit it, is it? Darn you. There we go. Nope. Oh well. Yeah, we'll do this the hard way. Guess we're going back to the old-fashioned way. I'm just using my drawing skills. Well, something like that. Pretend those look the same. I'm going to tell you this angle and this angle are the same. This angle and this angle are the same. That should be all you need to know. And let's say that this is 8, 20, 10, 18, X, 20, Y, Z, W, and P. Find X, Y, Z, W, and P. Okay, first, do we know what's our pair of sides that we know the numbers for in both figures? 8 and 20. Okay. So you either have 20 over 8 or 8 over 20. It really doesn't matter. It's just we've got to make sure we match everything else up. So let's say we're going to find X first. Where does X go, top or bottom? So X goes with the 8. So X is on top. What's going to be below it? Nothing. I gave you W on the other one, didn't I? So we can't find X right now. Let's see here. What do I want to make that? Let's make that 80. So that means 80 would have to go on bottom, right? So now what? Cross multiply and divide, what's X got to be? Well, you guys didn't have that figured out because I didn't give you the information for it. So it's going to be 32 if you cross multiply and divide. So then we have the 8 and 20 again. Let's find Y. Where's Y going to go? Well, Y is with the 20. It's going to go on bottom. It goes with the 10. Very good. So then what? Cross multiply and divide, we get 25. What'd you get for Z? 45 and P? 50. Perfect. I think you're ready for your quiz. I'm going to hand it out for you quick. Okay. So today is actually just kind of a vocabulary lesson for the most part. We're looking at polygons. And we've done some with the triangles and the quadrilaterals so far. When we talk about polygons, we're basically naming them by their sides. And we start out with, of course, the number of sides is also equal to the number of angles. But when we're talking about polygons, we are generally talking about the number of sides. The number of angles just happens to be the same. So let's say we have a triangle. Now, again, I just said we're naming them for the sides, not the angles. And the first one has angle right in the word. But, of course, we know triangles have 3 sides. Next, we're used to talking about rectangles and squares, but those are really part of what we call quadrilaterals. Quadrilateral has 4 sides, yes. What would be 5-sided? Pentagon, yes. Interesting that Colt knew that one right off the top of his head. 6 sides. Hexagon. Now there is a 7-sided one, sometimes called the septagon, sometimes called a heptagon. 7 sides in construction is generally not useful because you usually stick to, a pentagon occurs in some cases, but generally other than that you stick to even sides. Like 6, you'll jump up to 8, which is called a octagon. You'd have 9, which is a nonagon, but again, 9 sides usually doesn't occur in construction. 10 sides would be a decagon. You got it. If you go up to 12 sides, it's called the dodecagon, but we're not going to get into that. Generally, after that, it's just called an n-gon. An n-gon. Like, so it says it has 18 sides. It'd be called an 18-gon. Close enough, right? Or you can call it an 18-sided polygon if you wanted to do it the full term. Some things about our polygons. Regular polygon. Now, regular polygon does not mean it gets enough fiber in its diet. A regular polygon, if I'd have drawn that better, is one where all sides are equal. And all angles are equal. A regular polygon is also what we call convex. In a convex polygon, from the inside, all the angles are pointing out. So that's convex. This is not necessarily regular, but it is also convex. The alternative would be something like this. That is what we call concave, because this one angle right here is pointing in. The technical definition is a convex polygon, if you extend any of the sides, they stay outside of the polygon. And a concave one, if you extend this side, it cuts through the polygon. That's what makes it concave. But I've always thought, if you're inside, the angle's pointing out is a little bit simpler of a definition for me. So let's go back to a regular hexagon or a regular octagon. Pretend that's regular. We should be able to know what this angle here is going to be. We've talked a little bit about angle sum. What the total angles of a figure has to be. We know in a triangle it has to add up to how much? 180. The way we figure out the angle sum of any figure, did we go over this? Where the formula comes from? No, we haven't? Okay. Let's do this. Let's extend our sides. In fact, I'm going to do it this way. I'm going to extend our sides in one direction. So what we're going to do is we're going to walk around our triangle. If we walk around it this way, we get here, we're going to have to turn there, right? How far? You walk down this side, we get here, we have to turn here. Walk down this side, you get here, we have to turn here. How far do these turns add up to? 360. We make a complete turn. So those are 360 degrees. So I'm going to label this a little bit. I'm going to call this A, B, and C are the angles inside the triangle. This one will be D, E, and F. Well, we just saw that D plus E plus F is 360 degrees. But A and D have to add up to how much? 180. B and E have to add up to 180. And C and F have to add up to 180, which adds up to a total of 540, right? But we're going to, if you take out D, E, and F, we take out 360 degrees, which leaves us with the 180. Basically what this is, it's 180 degrees for each corner, then we subtract 360 for those outside angles. Make sense? So the number of angles times 180 minus 360 degrees. Now we could either leave it like that, or some people do it this way. Instead of doing the 180 the times n minus 360, they'll factor out the 180. So what's 360 divided by 180? 2, right? So right like this. It's 180 times n minus 2. Either one of those will work. So for a hexagon, there are how many angles? Well, 6 sides means there has to be 6 angles. So this will be 180 times 5 minus 2. What's 5 minus 2? 3. So 180 times 3 is 540 degrees. Where did I put the 5? Let me try that again. That shouldn't be a 5, it should be a what? 6, because it has 6 sides. So it'd be 180 times 4, sorry about that, which gives us a total of what? 720. Everybody catch that? I know I screwed that up bad. I don't know where the 5 came from. The number of angles. Well, if it's 6-sided, it has 6 angles too. Yeah. So 6 minus 2 makes 4. 180 times 4 is 720. So a hexagon has an angle total of 720 degrees. So if this is a regular hexagon, how much does each of these have to be? Well, I'm going to take 720 divided by 6, because there's 6 of them. Each of them has to be 120 degrees. So what I want you to do now tell me what is the angle inside of an octagon. What's this angle right here for an octagon? Pretend that's a regular octagon. So what do we start out with? It's 180. How many sides does this have? 8. So it's 8 angles as well. So 8 minus 2 would be 6. So 180 times 6, 1,080 degrees total. What are we going to do with that? Divide by 8 gives us 135 degrees. Very good. Now, I want to try this one. Can I trick you? Oh, let's do this. That don't work out so well. This will work out. If I give you that I have a polygon, it's a regular polygon, and its interior angle is 150 degrees. How many sides does it have? Well, it's just algebra. It's 180 times n minus 2 has to equal 150. Solve for n. Oops, sorry, not 150, but equals 150 times n, I should say, because it's 150 times the number of angles. Yep. So 180 times n is 180 n. 180 times negative 2 is a negative 360. What would be our next step in solving this? There's a couple different directions you could go. So you'd add 360. You're going a little bit of a long route, but it'll get us there. Yep. So then what? Subtract the 150 and so you got 30n is 360. Then what? Divided by 30 gives us n is 12. It's a 12-sided figure. A dodecagon. Okay. Well, I've rambled on for long enough. Let's give you guys some stuff out of the book to work on. Page 514 through 516. There's some stuff there on similar triangles and congruent triangles in the unit exercises. 1 through 10. And then also on page 528, those are also unit exercises. 1 through 24. This should be Unit 23 and Unit 24 exercises. I realize, I just basically blew through like a unit and a half, but this is all vocabulary stuff and hopefully stuff you've seen before. So I just wanted to make sure we have it all down before we start pushing into the trig further.